In the winters of World War II, cold killed quietly. Bombed cities lost gas lines, electricity grids failed, coal was rationed, and firewood was scarce. Civilians across northern and eastern Europe faced frozen nights inside damaged homes with nothing but salvaged timber and strict fuel limits. This is where, an almost unbelievable heating method returned from obscurity. A single vertical log that burned slowly from the inside out, producing hours of usable heat with minimal smoke, minimal fuel, and near total efficiency. It was not new technology. It was old, tested knowledge revived under pressure, and, it worked. What made this method remarkable was not comfort, but survival. One properly prepared log could heat a room long enough for families to sleep, cook, and endure nights that would otherwise drop indoor temperatures below freezing. Soldiers knew versions of it. Forest workers had used it for centuries. During the war, civilians quietly relearned it out of necessity. The heating log worked because it burned inward, not outward. Unlike a campfire that consumes fuel rapidly and wastes heat upward, the heating log was engineered to burn internally. A thick log, usually hardwood, was split vertically into 4 or 6 segments, then reassembled with narrow air channels between the cuts. Sometimes a hollow core was carved or drilled down the centre. When lit from the top, the fire crept downward slowly, feeding itself through controlled airflow rather than open flame. This internal burn produced steady radiant heat rather than intense flames. The outside of the log acted as insulation, keeping combustion slow and efficient. Instead of needing constant tending, the log self-regulated. This meant civilians could light it before sleep and wake to embers still producing warmth hours later. Modern fireplaces, they burn fuel fast because they're really designed for appearance and ventilation, not efficiency. The heating log, on the other hand, had no interest in aesthetics whatsoever. It was a functional object, meant to keep people alive. Nothing more, nothing less. Wartime civilians relied on physics, not on an abundance of fuel. During those wartime shortages, efficiency mattered more than convenience, honestly. Civilians learned quickly that surface flame just wasted energy. What they needed was controlled combustion and thermal mass. The heating log, it provided both. As the inner channels burned, the surrounding wood absorbed heat and radiated it outward over time. This created a stable temperature rather than those spikes of heat followed by cold. In small rooms, shelters or basements, this difference really mattered. The log functioned as both a heater and a heat battery, People placed these logs on stone slabs, brick hearths, or improvised clay bases to prevent heat loss into the ground. In some cases, civilians surrounded the log with stacked bricks or tiles to increase thermal retention, effectively creating a primitive masonry heater using almost no materials. The method spread quietly because it required no infrastructure. One reason this system never became mainstream after the war is precisely why it succeeded during it. It required no factory, no metal, no fuel delivery, and no permanent installation. Any person with an axe and basic knowledge could make one. In occupied regions, where smoke attracted attention, this method had another advantage. When burned properly from the top, it produced significantly less visible smoke than open fires. That made it ideal for blackouts and air raid conditions. This quiet efficiency is why, similar techniques appear in military field manuals, survival training, and cold weather expeditions long before modern heaters existed. The war did not invent the heating log. It forced people to remember it. The knowledge faded because, honestly, modern systems prioritize speed over resilience. After the war, centralized heating expanded rapidly. Gas, oil, and electric systems promised effortless warmth at the flip of a switch. The heating log, tied to manual labor and wartime hardship, was left behind. But modern systems trade resilience for convenience. When power fails, most homes lose all heat instantly. The wartime heating log functioned independently of infrastructure. It did not break. It did not require spare parts. It required only wood and understanding. This is why survival instructors, off-grid builders, and cold climate homesteaders have quietly returned to the concept. Not as nostalgia, but as insurance. You can apply the same principles today with modern safety awareness. The lesson is not to recreate wartime conditions, but to understand why the system worked. Controlled airflow, internal combustion, and thermal mass remain the foundation of efficient heating. Today, someone preparing for winter outages can adapt the principles safely by using thick hardwood logs, controlled cuts, and proper fireproof bases in outdoor or well-ventilated structures. The same logic applies to modern rocket stoves and masonry heaters, which are essentially refined descendants of this method. For campers, a vertical heating log provides sustained warmth overnight without constant tending. And, for emergency preparedness, knowing how to produce hours of heat from a single log can really be the difference between discomfort and danger. The key is not the object, but the understanding. Heat should be managed, not rushed. This forgotten system matters because it teaches resilience, not comfort. World War II civilians survived frozen nights not because they had better technology, but because they understood material behavior. They worked with fire instead of fighting it. They valued efficiency over spectacle. In an age where energy systems are increasingly fragile, this knowledge is not obsolete. It is quietly relevant again. If this kind of forgotten survival history matters to you, subscribe to the channel for more deep dives into the technologies that kept people alive when systems failed. Share this video with anyone who believes resilience is built, not bought.